What we have here is a stereo Bluetooth receiver, which is used to receive streamed audio via Bluetooth and produce a line level output, which you can then connect to your to an amplifier input or to powered speakers or whatever else you want. So this thing is very useful in that it can be connected inside the equipment that you want to turn into a Bluetooth compatible device. In my case, I want to connect this inside a tube radio that I've restored to give it Bluetooth compatibility, and the output from this will then go into the phono input of the tube radio, and we'll be able to receive streamed music. Now these things are available in various shapes, colors, and anything you really want. You can get these on eBay very easily. There are a number of models around. This particular one is a KRC-86B version 4.0, and it is Bluetooth 4.0, so it works fairly well. I've used it quite a few times, and with a few more components on here, we should get a very good system set up in that radio. So let me show you what we need to do. We have the connectors here on the end, which we'll use. Now, the bottom connectors I will not use. These bottom connectors are for making the controls available at the Bluetooth device. So you have things like volume up, volume down, skip back, skip forward, and so on. But I don't use those. What I do use is the row on the left. And starting from the top, we have in left, in right, and audio ground, which is for an auxiliary input, which again I don't use. So ignore that. The next one, not connected. Then we have the ones that really interest us here, which is out left, out right, and audio ground. This is the audio output in stereo from the device. So your streamed music or audio will come out here at close to line level, so ready to go into an amplifier. Those are the three connectors that we need. Then we've got three more non-connects, and followed by LED minus and LED plus. That's your LED, which is an indicator LED, quite useful to tell you whether you're paired or not. Then you've got not connected, and then you've got ground and VCC. Now that is your power supply, that's 5 volts. And that is what we need to produce. So normally you can get 5 volts from various sources. You can actually create a battery pack. 3 AAA batteries gives you 4.5. That'll work fine. Probably one of those 18650s at 3.7 volts should work fine, because this has a tolerance down to 3 point something volts. But if I was going to use a battery, I'd simply use one of these. And this is exactly the same thing, except it's self-standing. It has an input for auxiliary, an output for your audio, and it has a USB jack in there, socket rather, which you can use to charge the internal battery. This you can connect to any USB supply, and that charges your battery, and it gives you quite a good life, probably about 5 or 6 hours of playing time. But the point with this is that you need to charge it, and because I've got power supply on the radio, I prefer to go for a system that doesn't require constant charging, just to make it more autonomous and easier to use. So this one, for this purpose, is out. And what we're left with is this guy. And what we need here is we need 5 volts. So where do we get 5 volts? Well, we have a heater supply on the radio which provides 6.3 volts AC. One side of that is connected to the chassis of the radio, so that's ground. So we have 6.3 volts here, AC, and we want to get 5 volts out here. DC, preferably nicely regulated. And of course, ground. So how are we going to do that? Well, it's pretty simple. Because this AC supply is referenced to ground, we can't use a bridge rectifier. So we use a half-wave rectifier. With a simple silicon diode, I use a 1N4007, but you can use any suitably rated silicon diode. And then we put a capacitor, electrolytic capacitor over here to smooth that. That comes to ground. The capacitor I've used is actually one I have lying around. It's 2200 microfarads, and it's actually rated at 50 volts, which is overkill, but nevertheless it's there. So what should we get here? Well, what we're getting here is 6.3 times 1.414. That's root 2. We should be getting, oh, and then we have a diode drop, so minus 0.7 volts. And what we actually get over there is about 8.2 volts over here, DC. Now, because this thing is half-wave rectified, if you recall, half-wave rectified really does this to the wave. I want to reduce that ripple even further. And the way to do that is to use a pi filter with a resistor between another cap. And I'm probably going, this is probably overkill in terms of the cap sizes, but I've used another 2200 microfarads at 50 volts. Again, the pair that was lying around. And this resistor, I've used it quite small, 22 ohms, so that I don't get too much of a voltage drop. I do know that I'll need about 50 milliamps flowing through there. So the diode drop, the voltage drop across that resistor is going to be about 1.1 volts. So I should get over here 8.1, or rather 7.1 volts DC. That's what I should get over there. Now, I want this to be stable, really stable. So instead of just feeding that to the, with another dropping resistor or something like that, I'm using a regulator. In, out, and ground. Now this one is a 78L05. It is a 5 volt voltage regulator in a very small package, as I'll show you in a minute. And what we get out of here is 5 volts, provided we have about 2 volts difference between here and here. So to get 5 volts there, you need at least 7. It should actually be 7.5, I think, according to spec, but you need a high voltage. You get the dropout voltage over here. So the other thing they send you with this package of in the package that comes that the board comes in is actually 100 microfarad capacitor as well as the lead, and they suggest you put that right at the supply pins on the board. So we'll use that one as well, and that's 100 microfarads, provided it's more than 5 volts, but I think this one's about 16 volts. And we've got our supply. So that solves that problem. And we're going to build that and come right back. And here it is. What I've done is I've used a small prototype board. These things, again, you get on eBay. I bought a pack of them for about $5. And I have connected the actual board on here. This is another board, as you can see. I've connected the board on here. It's stuck to the lower board with a bit of that foam double-sided tape, just so it doesn't short. The 3 audio connections are made through to the bottom here. So audio ground, audio left, audio right. Those are your 3 outputs for audio. The 100 microfarad capacitor is in here. I've used a slightly better quality one. This is at 25 volts. The lead is in place. This lead will probably be moved elsewhere so that I can get a more direct visual indication of the pairing. The regulator is that 3-pin or 3-leg transistor-like device over there. That's the 78L05. It's a 5-volt voltage regulator. And the 2 capacitors with the resistor in between are there. There's the diode, and I've put a 1 nanofarad capacitor across the diode just to reduce switching noise. So this is my 6.3 volts in. This is my ground in from the 6.3 volts supply. And there's my output. And I have the 3 connections for the audio out. So this is built, and we're going to connect it to the radio and test it and see how we get on. So here we are. This here is the ground connection, or rather the 6.3 volts connection connected to the chassis of the radio. So that's our ground for the 6.3 volts. The other 6.3 volts itself gets connected to here, and I found a point on here that I know is a 6.3 volt point, and I've connected to that. Be very, very careful. If you get that to the wrong connection, you're going to have fireworks. Now I'm ready to switch it on. When I want to switch it on, I will just clip that over there. Okay? The output I have connected to the audio input, the pickup input of the tube radio. It's just temporarily soldered on there, ground left and right. So we're about ready to go, and what I'm going to do is I'm going to switch on the radio. I'll switch it on to pickup input, and we'll see what we get. Right, the radio is warmed up. Now I'm going to connect this over here and see if we get the blue light. The blue LED should come on to tell us that it's receiving power. Yep, we have power. Now, we had power. Is it there or is it not there? Switch it off. Well, it's giving us a bit of life. Let's connect it again. There we have it. It's blinking. That means that it is on and is looking for a signal, or rather a paired device or pairing device. Now, why did this thing fail? My guess is that we're getting too much drop-off voltage, too much drop voltage between the 6.3 and the input to the regulator. What I had back there when I first put it on is I had the light dimmer, the current limiter to the radio on, and I was getting about 210 volts coming to the radio. Now our voltage is supposed to be 230 or 240, so I had bypassed that, and when I went up now to 235, which is showing at the moment, this thing came on. So we have a very critical difference in voltage here. This voltage may be just too low, so 6.3 may just be too low for this voltage regulator to give us a constant 5 volts. But we do have it, all right? And I'm now going to pair the Bluetooth. We'll just activate Bluetooth. It's found KRC-86. Let's hit that. And it's connected. And what's happened here is the little blue light remains constantly on to tell us it's paired. Now I have some royalty-free music, which I'm going to play on here. And it's working. I can control the volume either on the device itself here, I can pause it, or I have full control of the amplifier here. Volume, bass, treble, and it works pretty well. So what's wrong with this? Well, we noticed for a start that if the line voltage is a little bit too low, this thing won't pair because it's not getting enough voltage. So that is an impediment there, because we can't be sure that we'll always have 235 volts. In other words, we can't be sure that this heater voltage is always high enough to give us the 5 volts to the output there. There is, however, one other problem, and that is that this thing creates a buzz. You can hear it there. Now, I have the volume on max, so it only happens at very high volumes, but it's still buzzing. And if I remove this, the buzz goes away. Now watch this. When I put it on, it takes a second or so, and when that thing starts working, the buzz starts again. Watch. Just gets worse when it pairs. Now, is it dramatic? Well, it only happens at high volumes, so I suppose the answer is no, it's not dramatic. But is it acceptable? Well, not really, not for me. So I have to come up with another alternative for this, and I know why this is happening. Because of the RF, or rather of the digital noise this thing's producing, this thing's been fed back into the ground line. Because we effectively have 2 ground points on this radio. If I remove this, watch, this is the ground for the supply. That still works. Now why is that? Well, the reason for that, and the buzz is still there at maximum volume, the reason for that is that this ground here, the audio ground, is actually linked to the power ground, and this audio ground is linked to the ground of the audio input, the pickup input, which is in turn connected to the chassis. So everything is grounded. You basically created a ground loop, but it's not the ground loop that's causing the buzz. If it were, that would have gone, and it's still there. It is actually the effect of the digital noise on the positive supply. And that is not acceptable, which is why if we connect this to a separate supply, I'll show you, we'll see if we get the same noise. Let's try that. Let's get rid of this. And we'll connect a separate supply to that. Now what I have here is plus and minus supply that is isolated. In other words, it's not referenced to ground at all, and it's not referenced to the same ground as the chassis or the earth of this radio. So I'm going to connect it on, and we'll see what happens. Switch on the supply. No buzz. Take it off. Switches off. There's a bit of noise when it disconnects. Switch it on. No buzz. So our problem then is that we need to use a separate supply that is not a reference to ground, as is the actual audio on this chassis. And the way to do that is to use, well, we can do it in various ways. As I said earlier, we could use a battery, but then we need to charge it all the time. And that's a pain. We can use a separate transformer that produces about, well, if we're going to use a separate transformer, we wouldn't use a 6.3 volt transformer because we do have a little bit of a problem with a lowish voltage. So we'd say use a 9 volt transformer and let the regulator do a bit more work. But we don't have to actually use another transformer. There's a trick we can use, which is to create another winding on the power supply transformer, the power transformer of this exact radio. We basically can create a secondary winding that's a 9 volt winding on the existing power transformer. And there's a particular requirement for that, which I'll show you in a minute, on how to go about creating that separate supply. And that requirement is a bit odd. It's mechanical, it's physical, but I'll show you. But if we do that, then we're getting a completely isolated AC supply here, which will then be rectified and regulated, and that should work a treat. So, and also it'll come on when you switch on the radio, because the power transformer will get power. It'll start supplying this guy. This guy will be on all the time when you have the radio on, but that's not a problem. But you won't have all the buzz going on. All right. So let me show you how I created another winding on the transformer of this radio. What you're seeing here is a 9 volt secondary tapping, or rather winding, on the existing power transformer. And the way to do this, it's very simple. The one requirement you do have is that you've got to have some space between the iron here and the windings to put a wire through. You know, you can use it's a pretty thin wire. This is actually too thick. This is, I'll tell you in a minute what this is, but it's actually too thick. You can use thinner wire. All you want to draw is about 50 milliamps. Let's call it rated for 100 milliamps. So very little current. It's got to be insulated wire. So you have to be able to pass it through there so you can wind it around. Okay? I found that this transformer has about a 2 millimeter gap on both sides, and I'm able to actually wind through a wire. Okay? Then what you do is you take a normal piece of wire like this, any wire. This is a solid core Cat5 wire that I just, took out of a Cat5 cable. It's solid core, and what you do then is you wind, say, 3 or 4 coils around here, connect that to an AC voltmeter and switch on your supply and see what voltage you get on there. In my case, with 4 coils, I got 1.2 volts. That tells me, rather 4 windings, 4 turns, that tells me that with this particular transformer, I get 0.3 volts per winding, per turn, okay? So I'm getting 0.3 volts AC per turn. I want to do 9 volts, so how many turns do I need? It's 9.0 divided 0.3, okay? And I get 30 turns. So I need to wind 30 turns of that wire around that core to get my 9 volts. And that's exactly what I have here. This actually, the Cat5 cable is 3 pieces of Cat5. I wound one round, left a fair amount on the end so that I can wire it up, wound it round, and then I got to the end of that piece, soldered another one on, shielded it with heat shrink, continued the winding, carried on till I finally got my 30 turns, and I can now measure it. Let me show you. So now if I connect the radio on, I've got the multimeter connected to that winding. There we go. I've got 9.3 volts AC out. Now all I need to know is whether the noise that I was getting is going to happen when I connect that 9 volts to the system that I have here. Let's try it. So I've repaired everything. I have the meter connected, so we can see the voltage drop when I connect the load. And I have the ground connected, or rather one of the AC connections connected. And I'm going to connect the other one. So let's have a look. There we go. It's come on. The blue lights come on. So it's actually working. And I'm not getting any buzz at all. It's absolutely silent. Okay? Which means that that is the way to power this thing absolutely silently and flawlessly. Now, it is quite a bit of work because winding that secondary can be a pain, but it works. And all you do now is clean up the transformer. I'll probably, join these guys together, put some tape here to hide that, the brown tape, so you don't even notice this. Make a marking on it, right on there, that it's 9 volts isolated supply. Somebody comes in the future will know what that is all about. And we're good to go. And then the other thing I'm going to do is probably put that little board inside a little plastic case like this, just to keep it neat. A little bit of Velcro tape on here, Velcro tape on the side of the inside of the radio. Maybe even bring the LED out so that I can see it, the LED. And this thing will just attach to the side of the radio with the output coming out here and the power going in the other end. And this should be done. Right, I hope that was useful to you. I've done this a few times. I've actually got away sometimes, depending on the board, you sometimes get away with so little buzz that it's not a problem. But this one actually was noticeable, and this radio has got some incredible speakers. Look at that. This thing as an amplifier for an iPhone source is brilliant. So I wanted to make sure that this one was particularly quiet, and using the 6.3 volts with that buzz, no matter how low volume it was, just wasn't acceptable, which is why I decided to go just that one little step further. And that's what we have here. Right, enjoy, have fun, and I'll see you again soon.